Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this video we'll be starting a new topic, that is op-amp, or also called as operational amplifier. Now the first thing that comes to mind is, what is an operational amplifier? So it is an amplifier. First of all, it is an amplifier that can perform different operations. Okay, what kind of operations can it perform? If I list down the operations, the basic operation is an amplifier. Then it can be used to realize a filter. It can be used to realize oscillator. It can be used to realize arithmetic circuits. That is the circuits used to obtain addition, subtraction kind of function. So these are some of the major functions of an op-amp. So op-amp is nothing but it is a special kind of amplifier which can be used to realize certain operations. Now the standard definition of op-amp is it is a high gain DC coupled amplifier. Okay, it is a high gain DC coupled, or you can say electronic voltage amplifier, because it cannot be used to act as a current amplifier. It will always be a voltage amplifier. Now many of you who have studied the multi-stage amplifier in BJT are aware of the direct coupling. What does direct coupling mean? Direct coupling means that the output of first stage is directly connected to the input of the second stage. That is, we don't have any components between the output of first stage and the input of the second stage. There is no intermediate components. We will directly connect a wire at the output of first stage and it will then be connected to the input of second stage. Are you getting my point? Direct coupling. So in BJT, in multi-stage amplifier, I have told, see, many of you might not have seen multi-stage amplifier because it is not in electrical gate course. That is why I am giving an overview. I told in multi-stage amplifier that there are three types of coupling: RC coupling, then direct coupling, then transformer coupling. RC coupling means that between the two stages there will be a resistance and a capacitance. Direct coupling means there will be no component between the two stages, and transformer coupling means there will be transformer connected between the two stages. So in op-amp, what kind of coupling we are using? We are making use of direct coupling. Remember this, because a small objective question I can frame about the nature of coupling in an op-amp. Now op-amp has a very high gain. The gain of op-amp is of the order of 10 to the power 5 to 10 to the power 6. Now for that to happen, what we need to do is, we need to have a multi-stage amplifier. In BJT we have seen a single stage can provide gain like 100, 200, 500, but not such a high gain. So to obtain such a high gain, we have to have multiple amplifiers connected in cascade. The first stage of op-amp is a differential amplifier. Differential amplifier we have covered in ECE GATE course. And what is the nature of this differential amplifier? It is dual input and single ended output. That is, there are two input terminals and only one output terminal. Those of you who haven't gone through differential amplifier, it means two inputs and one output. Okay. So that is the nature of the differential amplifier that is being used in the op-amp. But what we do with an op-amp? I told you, op-amp is an amplifier which will be used to realize certain operation, and in order to do that, we have to connect external components. We have to connect external components such that gain, bandwidth, impedance are controlled by external components. Okay, we don't want the original values of op-amp to be maintained. We want to have a control over these parameters. Like I want to have a desired value of gain. I don't want to have exact value of gain to be 10 to the power 5 or 10 to the power 6. Okay, I don't want that to happen. So in order to do that, we have to connect external components such that gain is a function of the value of external components. Okay, now op-amp is a linear device. Linear device means that the output voltage is A times the difference of the two inputs. I told you there are two inputs, or you can write like this: A V1 minus V2. Because it is a differential amplifier, it will always amplify the difference of the voltages. And if it amplifies the difference of the voltages, output will be gain multiplied by the difference of voltage. Okay. So op-amp is a linear device, and the first stage of op-amp is a dual input single ended output differential amplifier. Okay. So these are some common points about op-amp. So even if you want to remember, what you have to remember, op-amp is an amplifier which will be used to realize certain function. Second point, op-amp uses direct coupling out of the three types of coupling. Now in this video, I will be telling you about different kind of amplifier that we can realize, and it does not matter whether you are realizing them using op-amp, BJT or MOSFET. Okay, what are the common types of amplifier? The first type of amplifier that we have been studying till now is the voltage amplifier. Now this is the general model of an amplifier in which this part is your amplifier, and rest are external components like source and like load. Now in this diagram, if you see, this basically is a dependent source, and it is a dependent voltage source because plus minus we have marked. If it is a dependent voltage source, what does it depend on? It depends on Vin. So we will call it as voltage controlled voltage source, because it is a voltage source which is being controlled by voltage Vin. So it is Vc Vs. So a voltage amplifier is also called as voltage controlled voltage source. Now in this, if you find out Vin by applying voltage division, what it will be? Vs Rin over Rs plus Rin. What about V0? Again you can apply voltage division, KVin into RL over RL plus R0. Now if you want to have maximum V0, for maximum V0, V0 depends on Vin. I will say Vin should be maximum. How can you ensure that Vin is maximum? Now Vin is obtained by voltage division. So what can be the maximum value of Vin? The maximum value of Vin can be Vs. How it can happen? See, Vin is Vs over 1 plus Rs over Rin. Now if you write Rin tending to infinity, if Rin tends to infinity, the term inside bracket will tend to 0. So it will become Vs. So if you want Vin to be maximum, the input resistance of the amplifier should be infinite, and that kind of behavior we saw in MOSFET. Remember the hybrid pi model that I told you in MOSFET? In that I showed you the gate to source terminals are open circuited because there is no input current to the amplifier. So that is what I am saying, the input resistance should be infinite for Vin to be maximum. Now if you want the maximum value of output, it will be K into Vin. How can that happen? It can happen if R0 is 0. If R0 is 0, RL will get cancelled out. So V0 will be K Vin. That means this entire voltage will appear across the load if this R0 is 0. So what is the requirement of a voltage amplifier? The ideal requirement of voltage amplifier is that input resistance should be infinite and output resistance should be 0. But practically that does not happen. So we desire a high input resistance and a low output resistance. Okay, we desire these two things when we are talking about a voltage amplifier. Okay, even if you forget this requirement, this is very important requirement. One mark question I can directly frame upon it, but even if you forget, just try and draw the circuit that I have shown you, and then you will be able to identify which resistance should be high and which should be low. Moving to the second amplifier, the second one is called as current amplifier. In this, if you see, it is a dependent current source. On what factor is it depending? It is depending on In. So it is a current source which depends on another current. That is why it is also called as current controlled current source. Okay, it is a current controlled current source, or you can say CCS. Now in this also we will apply the same analysis, but instead of voltage division, since the resistances are in parallel, I will apply current division. So what should be the value of In? In will be Is. I am applying current division into Rs over Rs plus Rn. What about I0? Apply current division at the output side. Kin into R0 over RL plus R0. Now again for I0 to be maximum, first of all In should be maximum. Now Rs you cannot change because it is belonging to the source. We cannot change the parameter of the source. We are checking the requirement of amplifier parameter. Again amplifier is this much. So what you can change is the input and the output resistance, but you cannot change the source or the load. Source and load are independent. We can change the amplifier parameter. So if you want In to be maximum, what can be the maximum value of In? It can be the total source current Is. That is, I can say the total source current passes through Rn. That is the best case requirement or the best case that can be possible. Now that can happen if this Rn becomes 0. If Rn is 0, Rs will get cancelled, In is equal to Is. So this will happen when Rn is 0. Now for I0 to be maximum, you can write I0 equal to Kin. Take R0 in the denominator, 1 plus RL by R0. So now you can say that I0 is equal to Kin if R0 tends to infinity. If R0 tends to infinity, the term inside the bracket will become 0 and I0 will be becoming equal to the current source. That is, the entire current will go into the load. Why entire current is going into the load? Because resistance being infinity means it is open. If it is open, the entire current will flow in the load. So that is what I am saying. For maximum value of load current, the input resistance should be 0 and output resistance should be infinite. But that is the ideal scenario. Practically that cannot happen. So practically what we'll write? We'll say low input resistance and then high output resistance. That is just opposite of the voltage amplifier. The requirement of current amplifier is opposite, that is low input resistance and the high output resistance. Moving to the third kind of amplifier, transconductance. Now what is transconductance actually? This parameter we have seen in BJT as well as MOSFET. Transconductance is nothing but ratio of output current and the input voltage. That means at the output we have a current source, at the input we have a voltage source. It is a current source and it depends on voltage. So I will call it as voltage controlled voltage source. Okay, it is a voltage controlled voltage source, voltage controlled current source. Okay, so it is VCCS, that is voltage controlled current source. Now in this source what will happen is, first of all I will find out Vin. This is a series circuit, so which law should I apply? I should apply potential division. Vin is equal to Vs into Rn over Rn plus Rs. Okay. Now at the output side we have current source. So I have to apply current division. I naught is Gm Vn, that is the current source, into the factor of current division R naught over R naught plus RL. Again for I naught depends on Vn. For I naught to be maximum, Vn should be maximum. How can Vn be maximum? Vn you can write as Vs over 1 plus Rs over Rn. Again I told you, you cannot change the source and the load, you can only change the amplifier parameters. This much is your amplifier, okay? We can only change the amplifier parameters. Now if you want Vin to be equal to Vs, Vin should be equal to Vs. For that the denominator should be 1 and therefore the term inside parenthesis should be 0. So it can only happen when Rn tends to infinity. If Rn tends to infinity, the term inside the bracket will become 0 and Vn will become equal to Vs. Now for I naught to be maximum, it should be Gm into Vn. But when it can happen? Gm into Vn, what is the factor associated with it? 1 plus RL by R naught. It will be equal to Gm into Vn if the term inside the bracket becomes 0. It will become 0 if R naught tends to infinity. Okay. That means the input resistance should be infinite as well as output resistance should be infinite. But again, that is an ideal condition. Practically that cannot happen. That is why what we will say? We will say it must have high input resistance and high output resistance. Okay. So these are the two requirements that must be satisfied by a transconductance amplifier. Moving to the last case of amplifier, that is transresistance. It is basically opposite of the transconductance. It means del V out by del I in. That is the ratio of output voltage to input current and it will have the units of ohm. That is why the term resistance. Why trans? Because one parameter is being taken at the input and again other is taken at the output. Now this portion between the terminals is your amplifier. Okay, this is your amplifier. Now I want to find the value of V0. First of all, I'll find I in. The input side circuit is a parallel circuit, so I will apply current division. I in is Is into Rs over Rs plus Rin. Whereas at the output side we have series circuit, so I'll apply voltage division. It will be the voltage source multiplied by RL over RL plus R0. Now you want V0 to be maximum. Now V0 depends on I in. So I'll say I in should also be maximum. What can be the maximum value of I in? Tell me. I in should be maximum equal to the source current Is, right? And that will happen when Rn is equal to 0. If this Rn is 0, Rs will get cancelled out. I in will be equal to Is. Okay? And if you want V0 to be maximum, it can be maximum equal to Rm into In, but for that also R0 must be 0. If this R0 is 0, RL will get cancelled. V0 will be Rm into In, which will be Rm into Is. So ideally both the input and the output resistance must be 0, but practically what we will say? Low input resistance and low output resistance. Okay. And since at the output we are taking the voltage, this is the voltage source, but it depends on the current. If a voltage source depends on the current, it will be called as current controlled voltage source. So it is a current controlled voltage source, CCVS. So the nature of dependent sources that we studied in network is being given the name of different amplifiers in analog electronics like voltage, current, transconductance and transresistance type of amplifier. Okay, and this were called as the different types of voltage source when we were studying network analysis. Is it right? Moving on. If we compare the different type of amplifier that I have told you, we will compare the value of input resistance and the output resistance. What are the different type of amplifiers? First one was voltage, second one was current, third one was transconductance, and the fourth one was transresistance. Okay. For voltage amplifier, the input resistance must be high, output resistance must be low. Okay. And what is the nature of dependent source? It is voltage controlled voltage source. In current amplifier, the requirement is opposite. Input resistance should be high, output resistance should be low. Sorry, high. It is current controlled current source. In transconductance amplifier, both should be high, and it is called as voltage controlled current source. And in transresistance, both must be low. It is current controlled voltage source. So these are the four kind of amplifier that exist, and every amplifier can be classified into one of these four categories. So let me show you what kind of questions can be framed. See, the first question is find the voltage gain, current gain and power gain for a voltage amplifier. See this voltage amplifier, where we are given the input and the output resistance and the open circuit gain. So let me draw the model. This is your Vs. Okay, these are the terminals of amplifier. Here we will have R in. Okay, because it is voltage controlled voltage source. So input side also we will take voltage, and output side also I will take a voltage source. The open circuit gain is K. So the source will be KV in. Now see, it is a voltage controlled voltage source. The voltage source is connected in series with a resistance R0. These are the output terminals of amplifier, and then I will connect a load RL. This is your V0. So if I first find Vin is Vs into Rn over Rn plus Rs. If I find V out by voltage division, KVin into RL over RL plus R0. If you substitute the value of V in, you will write K Vs into Rn over Rn plus Rs into RL over RL plus R0. So the voltage gain would become V0 by Vs K Rn RL over Rn plus Rs RL plus R0. That is the voltage gain. Next we want current gain. For current gain I need I0 and I need Is. Now this Is is simply Vs over Rs plus Rn. Okay. And I0 is KVin upon RL plus R0. Okay. Or otherwise what we can do is, we can go by one more method, like Is is Vs over Rs plus Rn, and I0 is V0 over RL. So if you want I0 over Is, take the ratio. It will be V0 over Vs into Rs plus Rn over RL. V0 by Vs we already know. If you substitute the V0 by Vs, this RL will get cancelled out with the denominator. Rs plus Rn will also get cancelled. It will be KRn over RL plus R0. This is your current gain. Then what is the power gain? Power gain is simply the product of voltage gain and current gain. You can simply multiply these two gains and you will get the power gain. So such kind of question I can directly frame on the different kind of amplifier. Next question. Find the voltage gain, current gain and power gain for the current amplifier. Now for the current amplifier, if you want I in, you will apply current division. Is into this 10 kilo ohm resistor over 10 plus 1. I am just applying current division. So Is into 10 by 11. Remember, in current division, you will always keep the resistance in numerator which is not being used. If I want to find the current in 1 kilo ohm, in the numerator I will keep 10 kilo ohm. If I want the current in 10 kilo ohm, I will keep in numerator 1 kilo ohm. What about I0? Again apply current division. Kin into, which will be in the numerator, 10 or 100? We are finding the current in 10. So in the numerator we will keep 100. 100 over 100 plus 10. So Kin into 10 by 11. This K is given as 100. So 1000 by 11 In. You can substitute the value of In. It will be Is into 10 by 11. So 10,000 by 121 Is. So the current gain, which is I0 over Is, is simply 10,000 by 121. Okay. So what value will it come out? Check it once. 10,000 divided by 121. It will come out to be 82.644. Now if you want to find voltage gain, this is V0 and this is Vin. V0 is simply I naught into 10 kilo ohm. V in is I in into 1 kilo ohm. If you take the ratio of V naught by V in, it is I naught by I in into 10 by 1, that is 10. I naught by I in, or basically let us now go like this. V in will be IS is this current, into 10 kilo ohm parallel 1 kilo ohm. That is how much? Okay, I am going in terms of IS because I know I naught by IS. So IS into 10 by 11 kilo ohm. Now if you take V naught by V in, it is I naught by IS into 11. Okay. So I naught by IS is 82.644 into 11. So what will be the answer? Into 11, if you multiply the current gain, you will get 909.09. This is your voltage gain. So if you want to find power gain, you will multiply voltage gain and current gain. So 909.09 multiplied by 82.644, you will get 75130. Okay, 0.9. So that will be your power gain of the amplifier. Remember, power gain is always the product of voltage gain and the current gain. Moving to the next problem. Find the operating point VBIB if the characteristic of the device is given when 5 volt is applied to the device. Okay. Now see, here VB can be written in this circuit 5 minus 1 into IB. I am assuming that IB is in milliampere. That is why kilo into milli will become simply IB. We are given the characteristics also. Now when you know the characteristics, what you can do is you can write the equation. How you will write the equation? First of all, we will have to find the slope. Slope is delta y by delta x. 1 milliampere by 0.2 volt. So 5 milliampere per volt. So how will I write the equation? Y minus y naught equal to m x minus x naught. So x naught comma y naught is this point, 0.5. So IB is 5 milliampere into VB minus 5 milliampere into 0.5, that is 2.5 milliampere. If you substitute from here, I can say IB is 5 minus VB. Okay. So 5 minus VB is equal to 5 VB minus 2.5. So 6 VB equal to 7.5, or VB is 1.25 volt. What about IB? 5 minus 1.25 is 3.75 milliampere. So that is the operating point VB comma IB, 1.25 comma 3.75. So if I summarize what we have covered in this video, I have told you about different kind of amplifier. The first one was voltage amplifier. In this, Rn was high, R0 was low. It was called as voltage controlled voltage source. The second one was current amplifier. In this, Rn was low and R0 was high. It was current controlled current source. Then the third one was transconductance amplifier. In this, your Rn was high and R0 was also high. It was voltage controlled current source. The last one was trans resistance amplifier. Here Rn was low and R0 was also low. It was current controlled voltage source. Okay, so these are the basic 4 kind of amplifier, and we will again encounter this when we will be studying about the feedback amplifiers. So from the next video onwards, we'll get into op-amp directly. This was just the basic of different kind of amplifier. Thank you.
So for 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250. With code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me, and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil, and Telugu, JE channel, Computer Science, Gate Question, and Electrical Junction, Pathshala, and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like, and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon, so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.